हेलो एवरीवन। आज हम कंप्यूटर ग्राफिक्स में देखने वाले हैं चैप्टर नंबर 3 ओवरव्यू ऑफ ट्रांसफॉर्मेशन। उसमें टॉपिक देखने वाले हैं 3D ट्रांसफॉर्मेशन। अब तक हम लोगों ने प्रीवियस प्रेजेंटेशन में 2D ट्रांसफॉर्मेशन एंड होमोजेनियस ट्रांसफॉर्मेशन देखे हैं और उसके टाइप्स देखे हैं। ओके, सो इस 3D ट्रांसफॉर्मेशन में आज हम देखने वाले हैं ट्रांसलेशन, देन रोटेशन, स्केलिंग, रिफ्लेक्शन। तो सबसे पहले देखते हैं व्हाट इज़ अ 3D डायमेंशनल मॉडलिंग ट्रांसफॉर्मेशन. So basically in 2D dimensional we are using x and y coordinate. So for 3D dimensional modeling transformation we are using extra x coordinate. So basically in 3D dimensional modeling transformation we are performing transformation matrices 4 by 4 elements, and for this we are using the fourth component as a homogeneous coordinate. Okay, so value for the homogeneous coordinate is 1. So for a 3D point we are consider it is a column vector and it is shown as or represented as x, y and a z. Z is a 3D point, okay, means 3-dimensional coordinate. Okay, and for 3D point homogeneous, as a consider the P, and the P is equal to x, y, z, and fourth one dimensional is homogeneous coordinate, that is 1. So for 3D coordinates we are using x, y, z and 1. So first we see the first topic is translation. So basically translation is same as the moving the object from one location to the another location. We already seen this in 2-dimensional and homogeneous transformation. So exactly same as we are seeing in 3-dimensional transformation. So in this first matrices is new value, okay, that is x dash, y dash, z dash and 1. Okay, you can say the new coordinates. Then the second matrices, it is the translation matrices. So as you see in a fourth column there is a value of tx, ty and a tz, right, and diagonally it is all are 1. Fine, and the old coordinates is x, y and z and 1. So basically the see this diagram, okay, if this is a point P, okay, and the coordinates are x, y, z, and if I want to replace is matrix representation of 3 equation. Okay, so we have to calculate new coordinates. So there is a equation R, x dash is equal to x plus tx, comma y dash is equal to y plus ty, and z dash is equal to z plus tz. So x, tx, y, ty, z and tz values are given, and we are how to find out x dash, y dash and a z dash. So basically tx, ty and tz are specifying a translation distance for the coordinates of x, y, z are assigned to the any real value. So basically translate at object by translating each vertex in a object. Okay. So the next topic is a scaling. Scaling means changing the shape of the any object, right? So already we see the scaling in two-dimensional and homogeneous transformation also, right? So same over here. First we see the formula of it, that is p dash is equal to s dot p. This dot means your multiplication sign, right? So we have a matrices, that is x dash, y dash, z dash and a 1. It is a new coordinates, okay, equal to scaling matrix, okay. So the sx, sy, sz are diagonally, and then the one value is a matrices, so it is easy to remember it. And into coordinates is all coordinates, that is x, y, z and a 1. Okay, so for solving the any problem of scaling you have to use this matrix. So basically by multiplying these two matrices, equations like s dash is equal to x dot sx, y dash is equal to y dot sy and z dash is equal to z dot sz. Okay, and the simple representation, or you can say the row vector representation, is like this: sx comma sy comma sz is equal to sx 0 0 0 0 sy 0 0 0 0 sz 0 and 0 0 0 1. Okay, so this one is a scaling in 3-dimensional transformation. Okay, now next one is a rotation. So basically rotation means rotate the object in 3-dimensional. So over here first coordinate the x, second is a y and third is a now is z. Okay, so rotating this object in 180 degree, and it is default rotating counterclockwise. Okay, so whenever it is counterclockwise, when looking along the positive half towards the origin. As you see in a diagram, the first one is a rotation of the x-axis of an object, second is a y-axis and a third one is a z-axis. Okay, so we can rotate the object in any degree, 180 degree, 90 degree, 45 degree. Okay, next. Okay, so in now this slide we are seeing the coordinate axis of the rotation. So we have 3 axis rotation, that is a x-axis rotation, z-axis rotation and a y-axis rotation. Okay, so equation is there, okay, and matrices over there and a formula also given in these slides. So first we see the x-axis rotation. So basically x-axis rotation are same as the 2D rotation. Okay, so see first the matrices. In a matrices, new coordinates are x dash yz, y dash z dash and a 1, okay, is equal to cos theta minus sin theta 0 and 0, right? Then sin theta, cos theta 0 and 0, then 0 0 1 0 and 0 0 0 1, right? So this is a same as the two-dimensional rotation, okay, and these are the old value is x, y, z and 1. So we get the formula P dash is equal to RZ angle into P, right? So whenever we multiplying the rotation matrices and a old coordinate matrices, or you can say the vector, then we get this equation, okay. So what is the equation? Equation is h dash is equal to x into cos theta minus y into sin theta, right? Then y dash is equal to x into sin theta plus y into cos theta, and z dash is equal to z, because this is a z axis rotation, right? Now we see the x axis rotation, fine. So in this x axis rotation, x dash value is x only, okay, and the value of y dash and z dash is cos theta and sin theta, right? So see the matrices, new coordinates is x dash yz, y dash z dash and a 1, and the rotation matrix for the x axis is 1 0 0 0. Why 1? Because this is the x axis rotation, that's why the matrices are 1 0 0 0, okay. Then second row is 0 cos theta sin theta and 0, third 0 sin theta cos theta and 0, and last row is 0 0 0 and 1, okay. So this is one, the x-axis rotation matrices are multiply with the new old coordinate, that is x, y, z and a 1. Whenever we multiply these two matrices, then we get this equation, okay. And we already know this formula, that is P dash is equal to Rx theta into P, right? In two-dimensional and homogeneous coordinates or transformation, the formula are same, okay. Now the third one axis is a y-axis, and for the y-axis you can see over here the y dash is equal to y. Now you have to change only the x dash value and y dash value, okay. So see first matrices, the first is new coordinates, okay, h dash, y dash, z dash and a 1 equal to the y-axis rotation matrices. Now your y value is what? Is 1, right? So x dash is equal to cos theta 0 sin theta and 0, and z dash is minus sin theta cos theta and 0, right? And last and not the least row is fourth one, that value are 0 0 0 and 1. Now it is also multiply with the xyz1 old coordinates. So same as if you multiply these matrices and these vector matrices, then we get this equation for y-axis, that is x dash is equal to, sorry, z dash is equal to z into cos theta minus x into sin theta, and x dash is equal to z into sin theta plus x into cos theta. Okay, and the formula is p dash is equal to ry theta into p. So for this rotation we have to remember, okay, this all matrices only, okay, and the formulas. If you are multiplying to these matrices, means the rotation matrices and the vector matrices, then easily get the equation for any axis rotation. Okay, so here also the summary is given for x-axis, y-axis and z-axis. So you remember only this one. Okay, now see the sharing. So basically sharing meaning is slanting the image, right? So in two dimension the transformation relative to the x and y axis to produce a distortion in a shape of the object, right? So in a three dimensional we can also generate the shades relative to the x-axis. So see this a image, it is a before sharing image, okay, and the B image is a after sharing a object. Okay, so you can see the difference before and after sharing. Okay, now let's see the what is a matrices. Okay, so this is for the sharing for z axis. Okay, so x and a y value is depend on the x value of the shape, right? Because we finding the z value. Okay, so matrices is 1 0 1 a0 0 1 b0 0 0 1 0 and 0 0 0 1. Okay, it is a z axis sharing. Now we see the for x axis sharing. So for x axis y and z are depend on x, okay, and the matrices is 1 0 0 a 1 0 0 b 0 1 0 and 0 0 1. So you have to remember this matrices. Okay, so in this slide we see that we divide the sharing transformation according to the direction of the surface, like xy, yz and xz, right? So value of the sx, sy and sz determine the sharing transformation of size for all the direction. Okay, so first we see the sharing transformation about the xy plane, okay, that is coordinate. So for xy coordinates we get the value 1 0 0 0 0 1 0 0 sx sy 0 0 and 0 0 0 1. Okay, now for sharing matrix about the xz plane, for this we get the matrices 1 0 0, okay, sx1, sz0, 0 1 1 0 and 0 0 0. Okay, and for sharing matrix about the Yz plane, that is 1 sy sz0, 0 1 0 0, 0 1 0 0, 0 0 0 1. Okay, if you see properly, the diagonally 1 1 is written. Okay, and first see over here. Okay, for x and y plane, you can see for third row, that is your z row. Okay, you have to write down sx and sy. Okay, because in this plane the z is not written, right? Same like for the xz and a yz. The next one is a 3D reflection. So basically the reflection in the computer graphics is a mirror image, as seen you can see in this particular figure. Okay, so reflection is a given axis equivalent to the 180-degree rotation, and reflection has a many types, that is x-axis, y-axis, z-axis, and also the xy plane, yz and yx plane, right? We already seen these things in 2-dimensional also and a 3-dimensional also. So now see the 3-dimensional reflection for the x-axis. Okay, so x dash is equal to x, y dash is equal to minus y, and z is equal to minus z. Why? Because it is a reflection for the x-axis, right? So which coordinates is not written, that is y-axis and a z-axis. That's why the y dash values is minus y and z dash is a minus x. Understand? So it is very easy to remember, because this reflection is same as the your identity matrix, and you have to only remember where you have to give a minus 1. Okay, so जो भी एक्सिस ओके लिखा हुआ नहीं है उसे आपको क्या करना है, माइनस कर देना है. ओके, सो फर्स्ट दिस वन इज फॉर द एक्स एक्सिस एंड matrices is 1 0 0 0, 0 minus 1 0 0, 0 0 minus 1 0 and 0 0 1. Okay, and you can see the figure also for the reflection of the x-axis. Now second is a reflection for y-axis. See the diagram also. Okay, and the equation are y dash is equal to y, x dash equal to minus x, and z dash is equal to minus z. Okay, so y dash है इसलिए value of the y dash is a 1 and both are minus minus. Okay, y dash की value क्या होगी, positive, and x dash and y dash is a negative, that is minus 1. See over here, minus 1 0 0, 0 1 0 0, 0 0 minus 1 0, 0 0 0 1. Okay, and next one is a reflection about the x-axis, z-axis. So z is a positive and remaining one are the negative, right? So what is the matrices? Minus 1 0 0, 0 minus 1 0 0, 0 1 1 0 and 0 0 1. Okay, means what you get in this equation of the x-axis, x dash is equal to minus minus x, y dash is equal to minus y, and z dash is equal to z. Okay, now you see the reflection for the xyz plane. Okay, so this one, okay, the first one image and matrices for the y and z plane. That's why the x की value is -1. Okay, then in a next diagram, okay, the matrices for x y plan, because z value is -1. Then third is for x and z plane, because y is -1, right? And this last one is for the origin matrices. Okay, so you have to remember that कि जो माइनस है, ओके, जिसकी वैल्यू क्या है, माइनस है, वो हमें कोऑर्डिनेट्स क्या नहीं करना है, काउंट यहाँ पे नहीं करना है. ओके, इट इज़ वेरी इजी टू रिमेंबर. सो इस पर्टिकुलर प्रेजेंटेशन में हमने 3 डायमेंशनल ट्रांसफॉर्मेशन देखे. ओके, दैट इज ट्रांसलेशन, स्केलिंग, रोटेशन, शेयरिंग एंड रिफ्लेक्शन. ओके, एंड जो भी आप यहाँ पे 3 डायमेंशनल पे ट्रांसफॉर्मेशन करने वाले हो, ओके, वो 4x4 मैट्रिसेस में क्या होने वाले हैं, हम करने वाले हैं. ओके, सो नेक्स्ट प्रेजेंटेशन में हम सम सॉल्व करेंगे फॉर 2 डायमेंशनल, 3 डायमेंशनल एंड होमोजेनियस कोऑर्डिनेट्स के ऊपर. थैंक यू.